All right, guys. So for today, we're going to do in chapter 7.5, again, rational equations. And that's our goal for today, is just to solve these things. We're going to solve for x in this case. And what we're dealing with, guys, is, dare I say, fractions. Okay. So what we have is a bunch of fractions, and we want to get rid of those fractions. We want to make this as easy as possible. Okay. So if I take a look at example 1a, I have 3/5 equals x over 2 and then plus 1/4. And what we're trying to do is solve for x. Well, we want to get rid of these denominators here, and I've highlighted the 5, the 2, and the 4. What we need to do is identify what the LCD is of between 5, 2, and 4. All right, so 5, 2, and 4. I start at 5, and I work my way up. So I start with the biggest guy. And how do I get an LCD with multiples of 5? So 5, 10. 10 works for 2 and 5, but 10 doesn't work for 4. So then I do 15, then, 20. So I take a look, I say, well, I got 20 is the perfect LCD. So what I'm going to do is I'm going to go ahead and multiply everything by that LCD. I'm going to multiply everything by 20 here. We're going to do a little math magic. We're going to wave our hand, do-de-do-de-do. And then all of our denominators are going to disappear. Okay, so I take a look. Take the 20 and divide by this 5. That's a 4. And now multiply. 4 times 3 is 12. I take this 20, I divide by 2. 20 divided by 2 is 10. And now 10 times x is 10x. And last but not least, I've got 20 divided by 4 is 5. And then 1 times 5 is 5. So I have 12 equals 10x and then plus 5.
Mr. Gotsch, a question.
Yes, ma'am.
Could you record this?
I am recording it.
Okay.
So again, the big idea, we're just multiplying by the LCD. So we multiply all of these guys by the LCD, and then do-de-do-de-do, all these denominators that I have highlighted have been disappeared. Now this is pretty easy to solve from here, right? We want to solve for x. We're going to go ahead and subtract that 5 over. So now we get 12 minus 5 is 7 equals 10x. And then we divide. So final answer I get is 7 over 10. Okay, and that's it. Hi, buddy.
So everybody should not.
Hang on one second, guys. Hey, can you get this little guy? All right, do you guys have any questions with that one? All right. So I take a look at the next one. I got example 1b. I always like highlighting my denominators. I like highlighting the 6 and this 12 here. So I've got x minus 3 over 6 equals 7, and then minus x over 12. So I like highlighting those guys. And now I got to come up with the LCD between 6 and 12. So let me zoom in so you can see this nice and big here. All right, so LCD. Well, guys, what's the LCD of 6 and 12? What do you got? Taylor, Eddie, Mariana, Isabel, Michael, what do you guys got for LCD between 6 and 12? You guys can use the chat. You can use your microphones.
Is it 12?
Yeah, it's just 12. So I go ahead and multiply everything by the LCD, which is 12. Okay, so I'm going to put a 12 here. I'm going to put a 12 here. Okay. Now, when I look, there's really 1, 2, 3 things here. So I have to multiply the 12 to the 7 also. Even though it doesn't have a denominator, I still need to multiply it by it. The idea is I multiply both sides by 12, and when I do that, I've got to distribute. So what I'll do is I'll just multiply and put a 12 next to everything, okay? So now we do a little math magic. Doo-dee-doo-dee-doo. Anything that's highlighted is going to disappear. So I got 12 divided by 6 is 2. And now I have 2 times x minus 3. Okay? So now, usually what I do is I'll go ahead and distribute all in one step. So I get 2 times x is 2x, and 2 times negative 3 is negative 6. So the next one I've got is 7 times 12. And you can grab your calculator if you need to. 7 times 12, what is that? 70, 84? Is that right? And then last but not least, this 12 that's highlighted reduces that 12. And that leaves me with negative x. Okay, so I did a little math magic here. All right, multiplied everything by 12. All of those highlighted denominators have disappeared. And now we just have a basic algebraic expression. We know how to solve this. Get the x's on one side, add the x over. So that's 3x. I'm going to go ahead and add this 6 over to the other side. 84 plus 6 is 90. And then we can go ahead and divide over. And we finish up with x equals 30. Okay. Guys have any questions with that one? Again, it's baby steps. We're going to progressively get a little bit tougher. But that one's not too bad. Okay, so let's move on. If nobody has questions, try to get you guys out early today. We get out here normally at 12:30. Try to get you out at least 10 minutes early. Let's see what we can do. All right, so we take a look at the next one. Oh my gosh, look at all these denominators. I've got x, I got 3x, and I got 3. So my goal is to make those denominators disappear. Okay, so I need the LCD. All right, what's the LCD? What do we got? Use your chat, use your microphone, shout it out. What's the LCD between x, 3x, and 3? Juliana, what do you see? Riley, what do you see? Maddie, what do you see? Destiny, Kai, use your chat, use your microphone. What's the LCD?
Am I allowed to answer?
Sure.
3x.
3x. Boom. 3x is my LCD. There we go. So I'm going to take all three of these guys and I'm going to multiply by 3x. So I'm going to put a 3x there, a 3x there, and a 3x there. Okay. Again, I don't like fractions. You don't like fractions. Let's get rid of our fractions. So we multiply everything by that LCD. And then we go doo-dee-doo-dee-doo. And then all of the denominators are going to disappear. So 3x divided by x, the x's cross out. And now we get 3 times 7 is 21. Here, the 3x divided by 3x completely reduces and leaves me with a negative 1. And then last but not least, that's equal to the 3's reduce. And now I get equals 8 times x, which is 8x. So we simplify. We know 21 minus 1 is 20. If you guys are lost, say something. We're going to divide over the 8 and finish up. What is this reduced by? What, 4? right? 20 divided by 8 reduces by 4, so 20 divided by 4 is 5. 8 divided by 4 is 2, so we end up with 5 halves. So make sure R, when you're putting this in my math lab, you reduce that thing. Okay. If you're not very good at reducing, 20 divided by 8, my calculator, math fracket, it does it all for you. Okay. Now, I'm just going to talk about it. You won't see this, but technically, we should talk about it. Reminder, you can't divide by 0. So if we ever got something here for our solution and we plugged it back in and made the denominator 0, technically, we would have to exclude that from the solution set. So for some reason, let's say we had x equals 0. Well, if I plug that in, I would get 7 divided by 0, and that's undefined. So we'd have to say, well, then there's no solution if 0 was the answer. Okay? All right, give me a thumb. At least give me a thumb that you guys are listening and paying attention and writing this stuff down. Most of you guys don't have your cameras on. Oh, my gosh. Isabel turned her on, so I see a thumb. Thank you, ma'am. Ethan, how you doing, bud? You doing all right? Kai, thank you, bud. Appreciate it. All right, guys, let's finish up. Maybe get you to do B here. So I'm scooching. If you got your packet, I'm moving on to the back side. I want to do maybe 2 more. Okay. So I want to do this guy here, B. Okay. So what I've got is x divided by x squared plus 9x plus 20 plus 3 over x plus 5 equals 7 over x plus 4. Oh my gosh. I got all these denominators here. I got this trinomial. I got this x plus 5 and x plus 4. I got to get those things to disappear. Well, my little trick here is anytime I have a trinomial, okay, I want to try to factor that thing. All right. So we got to come up with factors of 20 that add up to 9, guys. So I'm going to factor it right underneath. Okay. What are factors of 20 that add up to 9? It seems like, Lily, you are the only one that has a microphone that works today. Factors, 20. Let's see. Jenny, do you know? Yes, I know. Factors of 20 are 5 and 4. Good job, Jenny. Jenny, you guys know Jenny. Good old Jenny. Look at her. She just factored that thing for you. What a nice gal. Okay. So I'm going to cross off this denominator here. That's the new denominator. I've just factored that guy. So I'm going to go ahead and highlight that. That's what we want to eliminate. We want to eliminate x plus 5 and the x plus 4. Okay. So LCD has to be at least that. So my LCD has to be at least x plus 5 and x plus 4 from our main gal, Jenny. Nice job, Jenny. No problem, Mr. Gotch. All right, so Jenny factored that for us. And if you take a look, that's got the x plus 5 and that's got the x plus 4. So that is a perfect LCD. Okay. This x plus 5 is going to eliminate that, and x plus 4 is going to eliminate that. So we're going to get rid of that highlighted part. Okay. So I'm going to go ahead and multiply everything by x plus 5 and x plus 4. So I know it's a lot of writing, but it's not too bad. Okay, so I've multiplied every single term by that LCD. Okay, now I'm going to wave my fingers, doo-dee-doo-dee-doo, and everything is going to disappear that's highlighted. So this x plus 5 and x plus 4 crosses this guy up. And all I'm left with is x. Look at that. Magic. This x plus 5 crosses this x plus 5 out. And I'm left with plus 3 and then times x plus 4. So 3 times that. And now I've got this x plus 4 crossing that guy out. And that leaves me with 7 and x plus 5. Look at that. So we took something super nasty looking. Oh my gosh, it scared me. But we made it super pretty now. Okay? And now, distributive property, you guys know that. So we end up with x, and then 3 times x is 3x. 3 times 4 is 12. Whee! Go ahead and distribute here. 7 times x is 7x. 7 times 5 is 35. And then we're just solving for x. We're getting the x's on the same side. I would probably clean up this right here. X plus 3x we know is 4x. So go ahead and subtract that guy over. 7x minus 4x is 3x. And I'm going to go ahead and subtract over the 25. So 12 minus 25 is what? Negative 13. And then finish up, I'm dividing by 3. So I get negative 13 thirds there. Okay. Again, if I plug that in on the bottom, it should be okay. Okay. If I, for some reason, got negative 5 or negative 4, if I plug that in here, that would make that undefined. So you have to double check that every once in a while. But again, I wouldn't worry too much about that. Okay?
Mr. Gotch?
Yes.
How did you get 25?
Oh, that's a 35. Sorry.
It's okay.
Couldn't even read my own writing there. All right, so we subtracted 35. Let's try that again. 35, negative 35 plus 12 is what, 23? Sorry. Sometimes my 1s and 2s look a lot alike. So that's negative 23. Sorry about that. So again, 7 times 5 is 35. For some reason, I had 25 there. Subtract it over. And then 12 minus 35 was negative 23, and we divided over. So final answer, negative 23 over 3. Thanks, Juliana. Extra credit goes to you today. All right, all right. Do we want to see one more? Do you guys want to see one more? How about C? I want to show you C one time. Okay, look at our denominators. I've got x plus 1, x squared minus 1. Okay. If I want those to disappear, I see something I can factor. Teach me how to factor. Factors of negative 1 that add up to 0 are plus 1 and minus 1. Okay, so I'm going to rewrite this so you can see it nice and big. All right, so I've got 3x over x plus 1, and that equals 12 over this x plus 1, x minus 1, and then plus 2. Okay, and we want this highlighted thing to disappear. So what we're going to do is we're going to multiply by that LCD. Well, if I take a look, the biggest one I have is x plus 1 and x minus 1, and that's going to be perfect as my LCD. That's going to cross this guy out and these two guys. So it's going to be perfect. Okay. So I'm going to go ahead and multiply everything by that. So I'm going to multiply everything by x plus 1, x minus 1, x plus 1, x minus 1, x plus 1, x minus 1. Okay. And then I wave my fingers. Do-do-do-do-do. Anything that's highlighted disappears. I've got 3x times x minus 1. Cross karate chop those. That gives me 12. And now I've got this 2 times these guys, okay? Well, we should know that this was x squared minus 1. So I'm going to take that. I went ahead and foiled that back. Okay, we factored that earlier, right? X squared minus 1, we factored this. So I'm going to eventually need to go ahead and foil that back so we can solve this thing. Okay. So we go ahead and distribute. Questions on where I'm at, let me know if I'm going too fast. We're going to go ahead and distribute. Oh, no, I got a x squared there. I got a 3x squared. That's okay. We know how to solve a quadratic. We did that in chapter 6. And then I go ahead and distribute here. That gives me 2x squared and then minus 2. Okay, so I'm going to rewrite this here. 2x squared, and then 12 minus 2 is 10. Now, it's been a long time since we did this. We want to solve a quadratic. When we solve quadratics, we get our stuff equal to 0. So we want to put these guys on the same side. We want to move this guy over using subtraction. And we want to subtract this 10 over. So 3x squared minus 2x squared is x squared. We get a negative 3x and a negative 10 equals 0. Okay. So now we factor. This is something what we did in chapter 6. We look to factor that guy. Factors of x squared are x and x. And then factors of negative 10 that add up to negative 3 are what? 2 and 5. One's a plus, one's a minus. This one's got to be the negative, so it adds up to a negative 3. And that's a positive 2. So again, if I check my outers and inners, my nose and smile, I would get a 2x and a negative 5x, which adds up to negative 3x. So not too bad. Solutions opposite of what you see. If you need to, set them equal to 0 and solve. I would add the 5 over. That'd be 5. And I would subtract the 2 over. That'd be negative 2. Okay. So again, if you need to, take each quantity and set equal to 0. Take x minus 5 equal to 0, set x plus 2 equal to 0 and solve it. If we add the 5 over, that's 5. If we subtract the 2 over, the answer is negative 2. Okay. I always double check anytime I get an answer and I had x's in the bottom. I just double check to make sure that wouldn't make the denominator 0, which it doesn't. So we actually get 2 answers there. We get 5 and negative 2. Okay. So on the OMG scale, on the oh my gosh scale, I'd probably put that at like a 6 or 7. Okay. Again, you had to do a little factoring. We multiplied everything by that common denominator. We distributed. We solved the quadratic. Okay. But those are all techniques that you know how to do. We've learned that throughout the year. Okay. So final answer for number 2C was 5 and negative 2.